Okay, good morning, friends. In last lecture, we started our discussion about the numerical illustration and also numerical of exercise. And also we discussed about due to the different position of an object, which type of the image and what is the position of an image and what about the magnification, we also discussed in last lecture. Now, today we are going to discuss about the illustration 2. In illustration 2 is also logical. Here in illustration 2, one mobile LED, that is not a smartphone, that is the old phone. Here, that is placed on the principal axis of a concave mirror in such a way that the B end of the mobile is at center of curvature of a mirror. Now, what should be the image of this mobile? We have to draw the diagram. For that purpose, to obtain the image of this mobile, first we take the one ray that is coming out from the point B and A. So this ray is parallel to the principal axis. This ray incident on mirror, and after the reflection, it must pass through the principal focus of the mirror. To obtain the image of B and A, at least the two rays are required. One ray is this parallel ray, while the second ray for B point, that is also coming out from the B point, passing to the principal focus and incident on a mirror. So after the reflection, it becomes a parallel to the principal axis. At point B dash, these two reflected rays meet at point B dash. Therefore, B dash be the image of B. Now listen, here what's happened? B end of an mobile AB is lying on center of curvature C. Therefore, its image is also formed at the same point, and also the side of the image is same as the original object. That is the not increase. Now, while the S we go from B to A, so here this different point of the mobile lies in the C and F. Therefore, its image is moving, or the image is obtained away from the C point. For that purpose, in B5, what should be the image of A? For that purpose, one is parallel to the principal axis. Second, coming from the A, passing to the BF point and incident on a mirror. After the reflection, it must becomes the parallel to the principal axis, and thus the both will meet at point A dash. So A dash be the image of B. Thus A dash B dash be the image of A. Now, what about the point A? While the point A end of mobile LED is between C and F points. So, its image obtained at far distance from C. It is also inverted. It is also inverted image is obtained. Thus, A dash B dash is an image of object. Now, the second question is that the magnification is any uniform? No. Why? Because for the different point of mobile AB, here the mobile is the linear object. Therefore, the value of the U and V for the different points of the mobile are not same. Now, magnification M is equal to minus V upon U. Here, for different points, U and V are not same, not remain constant or the same. So, magnification is not uniform. Is not uniform. Now, as we move the mobile towards the pole of the mirror, so what's happened? Its image is going away from the mirror. It means going away. Therefore, the magnification is increases. Therefore, the image is more distorted. It means the image is not the same shape of the mobile. Now here looks here. The B is as it is, while the A is image of the A is very large. Therefore, the distorted image is formed. Therefore, the magnification depends on position of an object, and image becomes more distorted. Image becomes more distorted. So this is the theoretical answer of this illustration, and we give this answer on the basis of, in last lecture we discussed about the different position of an object and which type of the image is obtained of this type of the object. Clear this thing? Okay. Now on the basis of this we have also start our discussion about the extra numerical. Okay, now after this discussion of the illustration 2, we are taking the same numerical. Here the numerical values are given, find the length of an image, of an object. For that purpose, here the one object AB, there is the rod AB of length 10 cm is placed on a principal axis of a concave mirror in such a way that the B end of this rod is lying at 40 cm distance, while the focal length of a concave mirror is 20 cm. Find the length of an image. For that purpose, so here the length of an object, AB, that is given as the 10 cm. Focal length F is given 20 cm for concave mirror. Find the length of an image. Length of an image. There is LDS we have to find out. What is the length of an image? Now, for this purpose, first we do the diagram like this mirror. That is the concave mirror. Object, the pole of the mirror is P. Now, object having the length is 10 cm, there is our rod is placed on a principal axis in such a way that there is the B end, there is the A end. Here the length is 10 cm. Okay. Here the focal length of a mirror is 20 cm. Therefore, radius of curvature is for a concave mirror. F is given the 20 cm. Therefore, radius of curvature R is equal to 2F is equal to 2 into 20. That means the 40 cm. Now the B end of the rod is placed in such a way that there is a 40 cm distance from the pole. Actually, there is the R distance. Therefore, the B end is lying at center of curvature of a mirror. Now, B is on C point. That means the center of curvature. Therefore, the image of B is also formed at the same point. Therefore, for B, the image distance is also 40 cm. Here, B end of a rod AB is at 40 cm. That means at C. So its image is also formed at same point. Therefore, V1 is equal to minus 40 centimeters. While for A point, while for A and O, for point A, this distance is, there is a U. U is 10 plus 40 minus 50 centimeters. Now listen, here A is more than C distance, therefore its image is formed between the C and F. C and F. Therefore the image of AB is formed like this. There is the radius, there is the radius. There is the image of object. For A and of A load, object distance U is equal to 10 plus 40 is equal to minus 50 centimeters. From where formula? One upon F is equal to 1 upon U plus 1 upon. Therefore, 1 upon V2 is equal to 1 upon F minus 1 upon U. Therefore, we obtain the V2 is equal to minus 33.3 centimeters. Substitute the value of F. F is equal to minus 20 centimeters and U2 is equal to minus 33.3 centimeter we obtain. Therefore, the length of an image, that is the LDS is equal to length of an image, that is this distance. So what is the value of BDS minus value of ADS? Already we obtained the BDS is equal to minus 40 centimeter. For ADS, the distance from the P is obtained, that is the minus 33.3 centimeter. Here, negative sign indicates the type of the image and position of the image. Here we are not considering the negative sign, only we take the positive sign, minus 33.3, therefore 7.7 centimeter length of the image is obtained. So this way, on the basis of the illustration 2, numerically we can also find out what is the length of an image. Clear this thing? Okay, that is very interesting and also very easy, only the use of mere formula. And now keep in mind that here the sign convention is important. If you forget positive or negative, so at the time for answer is not there. So be careful about the sign convention. Clear this thing? Okay. Okay, after the discussion of the illustration 2, now illustration 3 is that for a concave mirror, the radius of curvature is given to 15 centimeters. If the object is placed on the principal axis of a concave mirror at distance 10 centimeters and distance 5 centimeters from the pole of a mirror. Now, what should be the position of an image? Well, we have to find out the distance. The image distance and also type of image and magnification. For that purpose, we are using the mirror formula. And we also discuss about that at which point its image is obtained. And due to that result, the image distance is positive or negative. On the base of this, we say about the image is either real and inverted or the virtual and real. For that purpose, first, for concave mirror is given, the radius of curvature I is equal to minus 2 centimeters. For the concave mirror, radius of curvature and focal length both are negative. r is equal to minus 15 centimeter using the sign convention. Therefore, focal length f is equal to r by 2. Here r is equal to minus 15 divided by 2. Therefore, minus 7.5 centimeter. That is our focal length. Now, first, as we place the object at 10 centimeter distance from the pole of a concave mirror, therefore the object distance is equal to minus 10 centimeter. So, what should be its image distance of the V? So, for that purpose, we are using the mirror formula. Mirror formula is 1 upon f is equal to 1 upon u plus 1 upon v. Therefore, 1 upon v is equal to 1 upon f minus 1 upon u. Now, in this equation, we substitute the value of f as minus 7.5 and u as minus 10 centimeter. So, we can obtain the v is equal to minus 30 centimeter. Now, student, you have to substitute the value and calculate yourself how the v is obtained, minus 30 centimeter. Here, the image distance is negative. It means the image of this object is also obtained in the same side of object, like this way, that is shown in the figure. There is the principal axis, there is the pole P, there is the concave mirror, there is a f. And now, f is minus 7.5 and object distance is, what is given? 10 centimeter distance. Therefore, the object is placed here. So, there is distance, object distance minus 10 centimeter. So, image distance obtained minus 30 centimeter. Therefore, the image is obtained here. V is equal to minus 30 centimeter. Here, image is obtained in the same side of object, therefore the V is negative. V is negative, therefore inverted and real image is obtained and figure is and image is also magnified. After that, we are going to find out the magnification. Magnification M is equal to minus V upon U. Here we substitute the value of V and U with sign convention, therefore minus and minus 30 upon minus 10, this minus minus becomes the plus, therefore M is equal to minus 30. Here the magnification is negative, so image is here and inverted, and also the magnified image is obtained. Clear this? Okay. So in first case, by considering the object distance is 10 centimeter, we obtain the image distance, and from the image distance and calculation of the magnification, we judge about which step of the image is formed. Now, we are going to discuss about the second part. In second part here, the object distance is given the 5 centimeter. The similar way, we can also find out the image distance in that case. For that purpose, here, if the object distance is 5 centimeter, that means the half of this earlier first part, therefore object is placed here. So what's the one? So what we judge about that, at which point we obtain its image? So in last lecture we discussed about the position of an image corresponding to the different position of an object. Here, if the object distance is 5 centimeter, that is the smaller than the focal length f. It means the position of an object between the f and p. If the position of an object between f and p, so its image is obtained on the other side of the mirror. Therefore, its image is obtained this side. Therefore, the image distance is positive. Image distance is positive. Clear this thing? And due to the result, the magnification is also positive. Is also positive. Now we are going to calculate this thing. Clear this? Okay. For that purpose, now the second part here for object distance u is equal to minus 5 centimeter. Already we know that the f is equal to minus 7.5 centimeter. So from mere formula, 1 upon f is equal to 1 upon u plus 1 upon v. Therefore, 1 upon v is equal to 1 upon f minus 1 upon u. So here, by substituting the value of u is minus 5 centimeter, f has minus 7.5 centimeter. So we obtain v is equal to 15 centimeter. That is positive. That means the image is formed behind the mirror. Behind the mirror. Therefore, magnification m is equal to minus v upon u. Therefore, minus sign, v is our 15 centimeter. U is minus 5. This minus minus plus. Therefore, m is equal to 3. Here, magnification is positive. Therefore, m is positive. So that image is virtual and here. Virtual and so here in both cases the images are different. In first part the image is real and inverted, but in second part the image is virtual and real. And due to that reason these two cases are given. Clear? Okay, on the base of the illustration 3, we are considering the one more extra numerical. Here, for a concave mirror, the radius of curvature of a concave mirror is given as the 160 centimeter. And here there is a concave mirror, therefore, the radius of curvature we consider as a negative. Now, an object is placed on the principal axis of a concave mirror in such a way that its virtual image is obtained at 70 centimeter distance from the pole of a mirror. That means the image distance. Yeah, which type of the image is formed? That is the virtual. For virtual image, here the image distance is positive 70 centimeter plus. Find the position of an object. So we have to find out the object distance and magnification. U and also magnification. M. Again, the question is given like this way. For a concave mirror, the radius of curvature is 160 centimeter. An object is placed on the principal axis of a concave mirror in such a way that its virtual image is formed at 70 centimeter distance from the pole of the mirror. Find the position of object and magnification. According to this question, what is the figure? Now the figure is not important for this numerical, but from the figure concept becomes very clear. Here there is the concave mirror, there is the pole P. Now radius of curvature is given I is equal to 160, therefore focal length is 80 centimeter. Focal length is 80 centimeter. There is the center of curvature, there is the F. Here, the object distance is not given, but the image is given. Image is given. And image is given the 70 centimeter, therefore image is formed in this side. Image is formed in this side. Now the sun, for a concave mirror, I is equal to minus 160 centimeter. Focal length F is equal to R by 2 minus 160 by 2 is equal to minus 80 centimeters. That is our image distance. V is given as 70 centimeters. We have to find out object distance. U V to for that purpose, we are using mirror formula. So, mirror formula 1 upon F is equal to 1 upon U plus 1 upon U. We are interested to find out the object distance. Therefore, 1 upon U is equal to 1 upon F minus 1 upon V. Now, substitute the value of V and F with using the sign convention. So, we can obtain the value of U as approximate 33.3 centimeters. Approximate, calculate yourself, that is the negative. Okay. So that is the position of an object. And magnification, M is equal to minus V upon U. So it's equal to minus V. V is equal to 70. U is equal to 33 point. I think the 37 approximately. Whatever this you calculate, there is the 37. So it's there is negative. Therefore, negative, positive, so 1.89. There is the magnification. Okay. So thus the numerical we can also calculate the same numerical concave here. The radius of curvature is given 160 centimeter. Here, not we have to find out the image distance. Image is given. Which type of the image? Here the virtual image is given. So the base of the type of the image, we have to take the positive or negative value of V. Here the virtual image, therefore there is positive because the image is formed behind the mirror. And we need to find out the U. Therefore, using the mirror formula, we can calculate the object distance. Object distance becomes the negative, and we can find out the magnification. Here this. Okay.